So today we will revise the concepts of the object-oriented programming, and we will take a look at different classes and also the constructors that are used to initialize our classes. So the first we have covered some part of the object-oriented programming the last week. So the class, like we talked about it, is a category of object. So the class defines all the common properties of the different objects that belong to it. So our basic building structure, the class, it includes all the fields, properties, methods, and other elements that describe the specific entity in our world. And object, they refer to particular instance of a class. So when we have a class and we create an object, so it's like this instance will describe specific element that have the structure of the class. And objects have its own values of the fields and properties of the class. And the results of methods that are implemented for this specific object output the value. And the method, a combination of instructions so that they group together to achieve some result. And in the method, we have the input parameters, and usually the method outputs some result of the operations or block of code in which these operations are included. And the property is a member that provides a flexible mechanism to read, write, or compute of the values of the private field. When we have private fields in our class, we cannot address directly from our objects. We need to use a property to get the value or to set the value of the class. In the object-oriented programming, like in this scheme, we have the class. So lastly, we talked about the vehicle class, and we have these two big categories: the wheeled class, wheeled vehicles class, non-wheeled vehicles class. And they're also divided into more smaller categories, like the four-wheeled vehicle and two-wheeled vehicle for the wheeled vehicles. And the vehicles without non-wheels, they can move on the sea or on the air. And these are an examples of the methods and properties this object can have, like the color, manufacturer, carriage capacity, gasoline or electricity, and so on, and the methods that usually describe the movement, like we start, move, start to move, stop moving, we drive, and transport people, and so on. So you can extend the list of methods depending on the classes and the classes types you have. So there are also the four pillars of object-oriented programming that you need to memorize and you need to use: the inheritance, encapsulation, polymorphism, and abstraction. In the inheritance, you create a new class that extends the previous existing class that you have, and it will create more properties or more methods inside this class. So we have the base class. This is the initial class from which we create the inherited class that have more properties and the properties and fields and methods of the base class. In the polymorphism, we have the different forms, and these different forms are realized, for example, when the methods have the same name, but they have a different functionality. So depending on the input parameters, one or another method is used, and it is defined by the number or the types of the parameters it has. In the abstraction process, we usually show just only the part of the real instance in our world. So we don't show every single part of what our object have. That's because sometimes we don't need them, or sometimes it is enough for us to have this list of properties or fields, and we don't need to describe other else. In the encapsulation process, we have the data members and methods together, but some of them are have the private access mode. It means that we cannot easily have access to this property or field because they are hidden, and when we use the object, it is not possible to get access to it directly. In this case, we use properties, or we just use these fields or methods as public, so they can be accessible. In the methods, we have a block that contains a series of statements, and they are executed and they give some result. So for example, here we have the main method that have the following variables A, B, C, D. For example, it has some result and it realizes mathematical operations. In this case, we have the sum of two numbers and we display the message. And in our display message method, we only output some comments, some lines of text that help us understand what's going on. Here is a list of other methods, and the most important one is that if we have the method that returns some values, some result, we need to highlight the type of the method. Like this, whether it is integer or float or double or boolean or other types, or if it does not return, so we use the void keyword. If we use this keyword, we don't need to return any value. So this is very important. If you have the error here, it means you need to take a look whether your method returns anything or not. You can also use a reference in your method, and if your parameters are with the reference, it means that they are not formal, and the result of the operations will change the values of the variables outside of this method. But if you don't have the reference keyword in front of your parameter, it becomes formal, and the values are changed only inside the block of your method. And outside, if you have the variables with the same name, they are not changed because they are not seen by the method. It only works what is inside it. And when you have the overloaded method, as I have talked to you, whether we have, for example, the welcome guest method and welcome guest with a string name, if we use the method like here, welcome guest, and we don't have any internal parameters, it will call this method. And if we have some internal parameters, in this case it will call this method. Welcome guest, string name, and inside it we have some parameter, and inside the block we can output it. So let's continue with our lecture. So as we're talking about the inheritance, it allows us to create the inherited class from the base class, and this class has all the fields, properties, and methods of the base class, and it also has its own fields, properties, and methods. So it extends the functionality of the base class. And encapsulation, we just hide some properties and methods, fields, properties, methods, if we need them to be not accessible outside the class. These access modifiers are highlighted as public. Access is not restricted. We can get access to the fields or to the methods directly using the object of the class. If it is protected, it means that access is limited to the containing class, and it can be accessed from the derived class. When we use a private, the access is completely limited, and this method or field can be accessed only inside the class itself. So they can also be internal and protected internal. These are the special cases. So here we have the inheritance example. We have the class animal. This class animal had the string animal name, like this date time animal birth date, and it has a method public void feed animal. So this is a base class. Our inherited class is class dogs that has the following fields: dog breed, dog intelligence, and, for example, easy to train. So these fields are specific for the dogs class, but not exactly for other classes. Like if we have the birds, it is inherited from the class animal, but it doesn't include these fields. So it has its own fields: string, bird color, string, bird country. Although they have the specific fields, they also have these common fields: animal name, animal birth date, or feed animal method. So all of them are accessible for these two classes. So here is a picture that we have already seen. And this can be another example of the polymorphism. The polymorphism is important. It's the inheritance. If you have, for example, the class shapes, and inside it you have the draw method. If you want to have a specific functionality for this method in different classes, you need to use the virtual keyword. If you use this virtual keyword, it means that this method will be overridden in the inherited classes. So here we have the class circle, and we have the new draw method. I'm circle. It is not overridden. So this can be a problem when you call the draw method. If this is not overridden and you have the same name, it will call first the basic method of the class. But here in the class line shapes, the class line is inherited from shapes, we have the keyword override, and in this way this specific functionality will be called when you have the you use the keyword draw for the line class. And for the shapes, if you have the triangle here, when you use override, it will also show you the class, this method, I am triangle. So polymorphism means having many forms as one interface, multiple functions. Overriding allows you to change the functionality of a method in a child class. In the abstract class, if you have the abstract class, it means that its method cannot be cannot have the body here, and it means that this method will be overridden, and we have the this class shapes inherited, so we cannot create an object of this class shapes. It's already not available. So when we have the class line shapes, we can override it. So void draw, hi, I'm a line. So already it's a new method. And also let's take a look at the constructors and destructors. For a constructor is a public method that has the same name of the class, and it doesn't return any type. And it is called once the object is created. So once you create the object, you use a constructor, and depending also on the parameters you have, you can create different, you can have different constructors. So they can be passed one or more arguments. when you have the constructor with no arguments, then the compiler creates a default constructor. So there also can be more than one constructor associated with an object if this is useful. And each constructor must have unique signature. So it must have the unique types, number of arguments, and so on. So let's take a look at this example. We have the class myClass with the fields public string name, public byte age, and we have the following constructor myClass with the parameters string s and byte b. And inside this constructor, we use the assignment to the fields. Like here we have the assignment to the public string name and public byte age. Then we have the message of the class rewrite, like this. And when we start the class program, for example, use the void main, we create a new object, myClass x, new myClass Alexander 26. So it now calls this constructor. The name will be assigned Alexander and the age will be assigned 26. Then we write this. Then we call this method rewrite, and it will output the values of these fields. This keyword is important in the class notation because it allows you to address specifically the fields of the class if you have, for example, the same names of variables and you need to identify which one you call. So if we have an example with the public method complex, like here, that has the parameter real, double of the type double, and you want it to have the value this real, like, and it means that we have in our class this real field, and we assign it the value of this parameter, the real. When we address this, it means that we address the real variable of the class and we assign it the value of the parameter that is inside the method. This distinguishes between the past in real and the real of the current object instance. If you use a sensible naming strategy, you can avoid this vagueness, and sometimes it is preferable not to use it, but in any way you can use the same names if you wish inside your method and outside the class and outside class method. So another example, the full example, we have the class myClass with the method 1, and then we have the method 2, and the difference here we use with the char parameter is that in the first one here method 1 char, we addresses char here and we assign char to itself, so we just use a formal parameter. But here when we have char and we want to address this one, so we use a keyword this. Now it will address the variable, the field of our class, and it will assign it the value of the char parameter of the method. So this is how you can use it. And also let's talk about the static and instance members. The properties and methods can be either instance or static. So by default, properties and methods are instance, and this means that they are able to be used only with a specific instance of a class. This means if you don't have the static keyword, you can address something from the instance. If you have the instance method, you can create a new instance. Then you can use the method, you can call the method from it. But if you have a static data, static method, you cannot call it from your method. You can call this method from the instance of the class. In this way, you need to address the name of the class itself, and then inside it use the name of the method. So let's take a look here. We have class myCircle that returns an area. So public static double circle, square circle int radius, and we find the area of the circle. So we have the p multiplied by radius and multiplied by radius. Then we have the one circle that has the so the value where we have the p-value multiplied by radius, and it multiplies twice. So in this example, we will call the first method by addressing the class. So here we have the myCircle, we call the class, and then when we call the class method directly, like this, myCircle circle square, and inside it we put the radius. So in this way we find the area of the circle. And in this way, when we call one circle, we find the length of it. So again, it is a static, so that's why we need to call it directly using the class name. So for myCircle class name and the name of the method, the static double one circle method. So this is how we call it. So there are also the limitations for using static methods. In the static methods, there must be absent this reference, as such method doesn't work with any object. In the static method, allowed immediate can only other static method, but not an instance methods of the same class. So this, you need to memorize that static methods are directly accessible from the class and not from the instance, from the object of this class. So this is a key feature of the static keyword itself. So the static keyword can be used for methods, for constructors, for classes, and for properties. This static keyword. Here we have the static class, myMath. Static keyword. Then we have the static method round. Then we have the static method double. We have the static method square. When we find the value of the parameter squared in the second degree, and sqrt, the square root of the parameter double. So here we output the results of all these methods. Then we can have the overloading method. We have already made the overloading inside the constructors, so we can use the same logic for the methods. When we have the overloading methods, the one will be called that have the specific number of parameters and the specific types of parameters. Here, please take a look at the overloading. Here we have the empty method, UI. Then we have the method with the parameter string name, the username, and then we have the username and the family name inside this. String name, family name. And we have the right line for each of these methods. And then we create an instance of the class user info. This will be the object user1. If we call the user UI, it means this will be called. This method will be called. If you call this with the parameter string name, string last name, and string name, so this method will be called. If we add also the method with the age, we should write another call of the method with the 3 parameters. In this way, this one will be called. When we have the properties, we have already touched them at the last lecture, but in the properties, we need to use they usually used to work with the fields. So for example, when we have the class calculator, we have here a list of methods. And when we have this class calculator, another one and we have these two fields, int A and int B. So they are public, but they can also be private. So, and here also we have the method that returns the result of the mathematical operation with two fields. They are publicly accessible, that's why we can address them by the name. But if they are private, in this way we cannot address them directly from the method. That's why we can use a property. So here we need to type again the property with the set and get, as you remember. So we need to have this like this A, where we have the set when we assign the value. And if we have get, we will return the value. So return A. Like this. So in this way we can address our field A, and we can assign and get the value of the property of the field using this property. So this is our theoretical part of the lectures.